Hello there, welcome to the wonderful world of radio frequency and electronics engineering. Hope you're keeping well. On the bench today for a look at is actually a military radio transceiver. Very heavy one, weighs about, must be at least 20 kilograms. It's not something you want to drop on your foot. This particular transceiver I picked up from an auction fairly recently. I thought we'd strip it down and have a look inside, because often you can get some really good parts out of these military radios, because they're often built as a modular concept. So you have lots of mini circuits, modules inside, relays from Teledyne, which are extremely expensive to buy, particularly RF relays, mini circuit directional couplers and radial components as well from Radial France, and all sorts of goodies, you know, and they all tend to be built up from modules and things like that, especially some of the microwave military radio stuff that I have. But I've not seen one of these before, and it's actually made here in London, England, and we'll just zoom in on the manufacturer. So that's it. It's a transmitter receiver unit there, and it's Elliot Brothers Limited. So I'm not sure what radio system this is from. I've seen quite a bit of Ptarmigan equipment and over the years that I've had here. It's definitely obviously not Klansman. We've seen Klansman, Harris, some of the other radio from Raycall and various other manufacturers, Marconi, but I'm not sure. And it appears that this was made for a foreign market, because one of them that I have, it's actually written in French on the side here what these modules are, which we'll see perhaps on some of the others that I've got, because I've got about 5 of these. But I thought we'd strip it down and have a look. But again, it's really heavy, you know. I mean, this looks like it drops inside some kind of a like a mount that it slides into as a rack, and that's why you've got this handle on the top there in order to shift it. We've got a type N type port on there, one for transmit, one for receive, and obviously the other port rather is a C type, which is a larger version of a BNC really. So it's not a single antenna output, which I find interesting, unless of course this is an accessory antenna. But I think it says on one of them that I've got that there's a legend that says TXRX on the other one, because I have some of these that have got legends all over them printed on them, but this one doesn't. So I thought we'd just take it apart and have a look, see what it's made of. There doesn't look to be many connectors and things on it. There's that, what's it say there, something about built-in test. That's its NATO part number 5821-99-6498417. It's obviously got the radio transceiver information label there telling us it's a transceiver, so I'm not sure, but it's fairly robust. And if we have a look underneath at what's on the other side connector wise with regards to power etc., this is what we've got there for the power. So obviously got a multi-way, 2 multi-way connectors. I'm not sure what this is, this panel here behind there, and there's some weird thing in there, I'm not sure what that is. Something for test that goes inside there, like a captive storage thing. So yeah, thought we'd just take it a bit, see what's inside. I mean, for its weight, either it's made from lead or it's some other material, I don't know, but you'd be amazed at what you can find in these military radios. There's all sorts of precious metals, from gold, platinum, silver. There's quite a lot of, as I say, very expensive modules and components that's in them normally. So I'll get my screwdrivers and we'll start whizzing it apart. Okay, so I'll start with this front cover first, just to see what lay behind here. and I think there's another couple of screws just down there. It's quite heavy, I'll say that. I don't think it's a man-pack type radio, because you never get anywhere with this thing on your back, but it must be a vehicle radio, base type radio. Don't know what frequency it's on. Could be UHF, could be VHF, could even be HF, but normally I think the HF wouldn't have a type N on it. So, okay. Is it going to come off? Hopefully it's not like one of those Second World War radios from Nazi Germany, because they had booby traps in some of them. I remember when I was young reading Practical Wireless, I think it was, or the Radcom magazine, and there was always an advert in there warning people about purchasing certain military radios that had come from the Second World War from Germany, and some of the radios had booby traps in them, explosives, and they were still being sold at amateur radio rallies, some of them. So yeah, hopefully it's not one of those. I doubt it. Looks like we've got another RF type connector there because of the, or a signal connector in there, with that on the side, and then with a multi-way D type. But inside here just looks like there's some kind of logic assembly in there, something of that nature. So we'll strip that down. There's some logic thing in there which you might be able to see, but yeah, goodness knows. See whether we can start stripping this down. We've got this side. I've taken these screws out down there already, and these screws seem to be captive. They don't seem to be coming out, but I'll loosen them up anyway. It's like as if there's a nut on the other side spinning, but I don't know, because there's a little panel there, little tongue to get a screwdriver behind. So whether they're just captive and they are actually undoing the panel inside, I'm not very sure. But they're obviously separate modules. Let's see what we can find. Always interesting, these things. I've had lots of radar bits from aircraft and things, from fighter aircraft radar units, and you get quite some really expensive, very expensive parts in those that you can find very useful. Right, so that's not coming off. Definitely being held captive there somehow, so I wonder if you've got to undo these. I don't know. Just seems there's nothing apart from the two screws down there, which is holding that module in. So I'm not sure how it comes apart. It's not obvious. Since it's not obvious, I thought that undoing these two screws would allow these modules to be pulled free to come out, but they don't want to shift. And I can't see how that would come out. See, there is a screw there as well. Under each module there's a, oh, hang on, looks like as if there's a locking mechanism of some description. I don't know. Is that? No, it's not letting it come out. What's that one there? Is that one like it? That one's letting it come out. What? No. Right. Let's see if we can get that out. You see, it's not allowing that top tongue there. That's not allowing it to come out. Don't seem to want to budge. I think these screws have got to come out there. These damn things. Let's have a look here. It's very strange. Can't say I've seen these transceivers before. I do get to see quite a lot of the military stuff that's come out of, you know, the military for disposal, but this is an odd one. I've seen this transceiver type before. It's certainly bomb-proof. Makes you wonder. It's very heavy, so I don't know what that'd be fitted on. Must be a vehicle. Got to be like a modular system in a vehicle. Right. How do we get that off then? Just seems. Oh, that's better. So allowing that module to come out now. There's some connector underneath, maybe that's seems to be stuck. Oh, there we have it. Again, a modular. What's this say? Danger. V1, V2, V3 will contain beryllia, the dust of which is hazardous. So, but they've got RF transistors on that then. Volume squelch. So we'll have a look at that module inside. Let's see if we can get the other module out. It's just very strange. Right, so that definitely doesn't want to shift. That module doesn't want to come out. Let's have a look here. There's some information on the inside there. RX oscillator, RX signal UHF. So it must be UHF then. So looks like that socket there. Down there, look, is the RX oscillator input, obviously local oscillator, and then RX signal UHF comes in there. So that looks like it's a receiver module. I bet this is a transmitter module, is this? I'm just looking on the side of that. Oh, that's the synthesizer, it says. It says it's a synthesizer. Does this? Ah, yes. And this says on it there, that module that we've just pulled out, it says receiver. Is that module? So yeah, it'd be interesting to see inside. Right, I'll be back in a mo. Just going to see if I strip this damn thing down and get into it a bit further. Right, so we've got this cover off. This module at the end here doesn't pull out, it's covered with this, so we've got that off. And then looking inside, I've got quite a big deep transformer there with all sorts of diodes here as well. I think the diodes, just can't see how many legs is on them. I think there's only the one leg on each side, so yeah, they look like diodes. Got a diode symbol, and then we've got these transformer windings here. And they are actually quite deep then, they go down quite a way, the coils, they're very deep. So it looks like some kind of inverter. Got transistors mounted on heat sinks here as well. Looks like some kind of an inverter module. But it is actually quite deep when you look at it, you know, in depth. That's how deep the coils are and the former that it's mounted on. So yeah, quite impressive. Still can't get this module out yet. That's still captive. No matter what I do with this screw here, it tries to lift it, but it won't come out. So I think there's something on the other side that needs to be taken apart. So it's probably these screws need to come off, and then this side comes off, and there'll probably be a screw somehow on this side that locks the other module in place. So there's only 3 screws there anyway. I'm not sure if there's any on top yet. Shouldn't take too long to get into it, hopefully. Right, so there's a screw on top there as well. I've had a very expensive contract with screw manufacturers, the Ministry of Defence, when they built this. Probably if you're a screw salesman, you'd probably be on good money selling screws. There's one thing for certain, there's plenty in it. So let's just undo this. Oh, there's plenty in this. I don't like it, this screw. I get another one. Right, got all the screws out the bottom and the top now, so should be able to remove this, see what's inside this. Well, quite a bit, the look of it. Look at that. Plenty of things. Let's have a look in there. Let's see what we can see. Some RF stuff, and then a couple of SMA connectors with coaxial cable. And what does that say? Chassis electrical assembly. And this looks like it's some kind of filter assembly, the look of it. And then that looks like it's some kind of, again, another filter. It's a equally as long module, that down there. There's a circuit board there as well, and another module. So that's UHF transmitter with power amplifier, etc. And this AM. So it'll be interesting to get this lid off now, I think, and have a look behind there, see what the transmitter looks like. So hopefully there's something decent in it, and it's not just a load of junk I've bought, but until you take them apart you don't know. But I've had all sorts of interesting bits inside military radios. Lots and lots of directional couplers and all sorts of little bits and bobs. Amplifier modules that are being bought from Advantech or Anritsu, Marconi, AEI, Plessy, all these sort of modules inside. And you can't get data on them, obviously, because when they were originally manufactured they were secret, and so design data and things, but you can power them. Sometimes they have the voltages mentioned or labelled on the module itself, and you've sort of got an SMA connector, one on the input, one on the output, and it'll say plus 15 volts or plus 12 or plus 28. It'll give you a voltage idea, but sometimes they don't. Sometimes you just got to experiment, and there's guesswork with them, and there'll be no data on them. You know, some of these devices you can't get any information, but I like faffing about with things like that and experimenting and messing about. But some of the parts, you know, I've seen at some of these sales the Ministry of Defence have packaging on the components, the parts that they stock for repairing radios like this, and they have a label on the front and it says "Peel for price," and that's the price that the supplier charges the Ministry of Defence to purchase the part, the spare part. So it could be something like an RF connector or something like what's on there, that gold SMA connector. And you get a real surprise sometimes when you pull the stickers back, because you find out just how much the Ministry of Defence have been paying for things like little plugs and sockets and relays and things like that. And I think I remember saw a cement resistor, I think it was, in a pack at a radio rally I went to, and there's a guy there selling all ex-Ministry of Defence stock that had been sold off, you know. And I peeled back the label that said "Reveal price from supplier," and the resistor was about £141, you know, just for the resistor alone. You know, it's ridiculous. And connectors and things can, you know, be hundreds of pounds. ICs can be £30–40, maybe more, you know, depending on, you know, what radio it is and what supplier. But you get a bit of a, and switches are very expensive. Now here we've got a nice amplifier, UHF Power Amplifier. So I would estimate this sticks out quite some power in order for this module here, because of we've got, you know, 4 transistors there, quad amplifier there, and then an input transformer, input output matching to these, and then combined again for a singular output. We've obviously got architecture of RF in, RF out. Presumably these feed throughs are the supply and control voltages. Looks like we've just got one wire connecting there, linked to pin feed through 1 and 2, so that might be the first stage supplies. We've got pin number 4 there as well. We're able to trace that fairly easily. And then inside here we've got more wires. These might be doubled up so that they can carry heavy current, because there's only going to be like transmit enable, probably bias if it's an AM radio, obviously, because it's got to amplitude modulate, so it will have bias circuit providing bias to the base of these transistors. Again, you know, these transistors are very expensive to buy, and they are very useful because amateur radio transceivers that I repair sometimes need these kind of transistors in them, and you can get data on these. I've got catalogues with RF transistor data. This looks like the pre-driver, so we're obviously getting there's an input output socket there, if you like, so that's for the exciter PA rather. This is a final output PA, and then obviously it goes off there, as we can see, to a filter. So this looks like it's got probably a directional coupler in it, which senses VSWR, and obviously then starts to reduce the transmitter power for VSWR's high. And there's probably a power meter reflectometer in there, maybe directional coupler. So when we take that apart, it'd be interesting to see what's in it. And then this is probably the AM modulator for the transmitter. Now if we look carefully, we've got a coaxial cable. This white coaxial cable seems to go up into here, into that area. So I think that actually comes from this. So these modules are removable as well, because they're bolted to the middle part of this radio transceiver with a look of it. So it'd be interesting to see how we can remove those. But yeah, quite an interesting architecture. So let's just see if we can zoom in a bit on that for you, so you can see the UHF Power Amplifier in all its glory. So as we can see there, we've got sort of transformer. Now sometimes they use this wire, and it's got 2 conductors inside it, but I'm not sure if it is on this one because I can't quite see with this camera, but I think it's only 1. No, maybe it is 2 conductors inside it, but I can only see 1. there, but then it's using the outer jacket as one side of the transformer and the inner conductor as the other side of the transformer. So the inner of this goes through the centre of this coaxial cable and solders then to the outer of that, and likewise it's similar on the other side. So it's like an RF transformer, that's what it is. And then you've got decoupling capacitors there to obviously take it over to the next stage, which is the power amplifier section here. We've got a little track here that leads off. So this is obviously the base, I think, with the look of it. And then we've a track coming off here, and that goes to there. So I think this is connected under the board to probably one of these terminals. So that's the base, the bias to the base of the transistor to bias that on. Likewise, that's got another biasing network, this transistor there, by this radio frequency choke with printed RFC, and we've got a solder connection there. So yeah, interesting. And then that's the output transformer, and that's there too. So yeah, be interesting to see how much power that sticks out, but I bet it sticks a fair bit of power out, that, because, you know, typically just one of these transistors could probably do 30-40 watts, maybe even more, depending on its spec. So you've got 4 of them, so you know it's a significant amount of punch this can pack. And again, you know, we've got another one of these as a final driver there, as it amplifies it all up and then gets to this stage. So some of these things are quite easy to reverse engineer, you know, because of the common architectures and things, and you can then feed power to these. It may run off a higher voltage like 28 volts or 48 volts or something like that. That's something else, you know, to consider with these military type radios, because they all have these big inverters in them. But yeah, so quite interesting little bits. I don't know what's in the modulator. It could be a transistorized AM modulator, or it could be a transformer. Sometimes they use transistors to modulate the first stage. Normally the final amplifier is just constant CW amplifier without any control to it for amplitude modulation. But the first stage amplifier, which is this board here, often there's a transistor that modulates the collector voltage to the first stage. So then it's the actual supply voltage to one of these transistors that gets modulated with the speech for amplitude modulation, and that way then you don't need massive transistors or a huge modulation transformer, because the current that device takes is quite small in comparison to the rest of the amplifier transistors. I've seen on other radios like clear tone radios and things like that that do AM or X emergency service back in the good old days, they had a transistor modulator that modulated the first stage of a Mitsubishi power amplifier module. So you had first, second and third stages on the Mitsubishi brick, RF power amplifier brick, and I think I've got one here I can show you just briefly. But it would modulate sort of the first stage. So you've got like RF in first stage, and then on some of the modules you've obviously got second and third stage, and then RF out on the M pin. So to modulate the first stage with AM modulation, as in the supply voltage to that line will be modulated with the speech, and then these two will be connected together essentially in the circuit with plus 12 volts DC if it was a vehicle radio, things like that, and then that will be RF output. So this, if you like, is an integrated version of that. Obviously this is nowhere near as reliable as this and probably can't stick out as much power, although you can get modules like this that do you know, up to like 100 watts. But the military obviously go for this design for reliability, whereas these are commercial grade components. These are sort of, you know, obviously military grade. So that just gives you a little idea. Some of the older sets used to use modulation transformers. So one side of the secondary coil will be connected to supply, the other side of the secondary coil will be then connected to the collector of the transistors, and then the primary side will go to an audio amplifier, which would essentially be driven with your speech, and that then would influence the secondary side of a transformer with your speech. And then the supply voltage to the power transistors, these would be modulated with an amplitude modulated envelope, obviously because of your speech. After all that faffing about, there's not much to be seen in there, is there really, apart from just a few little PCB, little plug-in module. So yeah, we've got some power transistors there. Let's see if we can get a better view of that. And just got my magnifier so I can see. This looks weird. I don't know what that is. There's two wires going into that. I think this might be two TO3 transistors bolted underneath. Certainly looks that way because I can see the screws there. These are two power transistors, I believe. So they're probably what's used to modulate the actual power amplifier stage. So they could be modulating this board. I doubt they'll be modulating that board, although you never know. And then we've got obviously some specialist devices on here, and sometimes you get them where they rub the part numbers off the chips, so you can't reverse engineer it or tell which manufacturer it was. And quite a lot of transistors and things that you see in a lot of military radios don't have the part numbers on, so you know there's no intel on what they are. But in this one they've actually got some numbers on. Sometimes the original manufacturer's number, say it's a BC108 for example, that'll have a military part number on it instead, and then you wouldn't know then it was a BC108. And then other times there'll be no part number on it at all. Particularly the chips, there's a lot of stuff that I've got military wise where the chip numbers have been rubbed off, but they've left them on this, although this isn't an encapsulant that's on it, it's like an epoxy encapsulant on it, like a varnish that it's immersed in on both sides, so again making it more difficult for repair, but it's, you know, to guard against moisture ingress and protect the circuit and the components from harsh environmental conditions. Right, so we'll have a look at the other side now a bit more, see whether we can work at that somehow. But yeah, so that's like the AM modulator, and then we've got this here on this side. I'm not sure what this is. Might also be having something to do with the driver, but we've got some shenanigans going off up here in this corner. There's still things in the middle of the radio, obviously, down here in these modules as well. So it's like this half sort of splits off, I think, from the other. But again, there's more screws at the front here as well to remove. I think in order to get that half to split away, you've got to take all these screws out as well. So we'll just carry on removing screws and see where we get to. Right, this looks like this pulls out this module, so I'm just yanking at it trying to pull it off, but the I was just going to say as well, I remember as well, I've got a Mullard catalogue here. And Mullard here in the UK, long since gone to the wall, used to manufacture a lot of transistors and semiconductors for, you know, the military. And in the catalogue that I've got, often the transistors would have a CV number printed on them, Charlie Victor, and then you'll have cross-reference then in the Mullard catalogue that would cross-reference from the NATO CV number to whatever it was, like you know, a BC 108 for example, that kind of thing, or a SC 1924 or whatever. But you could tell then, but it wasn't always the case. But this is the first military radio I've opened in a long time where there's actually part numbers on the ICs. So yeah, quite interesting. Well, it's like a cassette. It pulls out, does this? I've undone 2 screws at the top, and then that sort of got the damn thing out. So we've got some intel there, look. But this is the board on the other side. That's that board in the middle. Again, everything's encapsulated, bonded down to the 8th degree. So again, this is the thing where component level repair, I suppose, when these went back to REME workshops or wherever for army radios, or if the Royal Air Force radios or whatever, they went back to a repair centre, it would be very doubtful they would do component level repairs because, as you can see, you know, these chips are encapsulated in a lacquer, like an epoxy, and there's no way you'd be able to get those out without really causing damage, you know, to the board, etc. And all these capacitors are all bonded in. But that's one thing that always amazed me as well about some of the military spares that I've had over the years. You get all these packets. I think I once had I always remember I had a real fancy RF plug once, and a bit like this, you know, they're really expensive. And I always remember I got this packet. It was in like a plastic tube with a lid on it, and you took the plastic tube off. Well, first of all, let me say, this plastic tube was wrapped in brown paper. And it was wrapped in brown paper, and I unwrapped this plastic tube and got all the brown paper off, and it was really well packed. I mean, whoever packed it must have been fantastic at Christmas present wrapping. But anyway, I'd remove this packet, and then there was a plastic cylinder tube inside, like a Smarties cylinder. And I thought, okay, whip the lid off that, and then inside was something about this size, but again, it was hard to tell what it was because that was wrapped in a bag, and inside the little bag, the bag was really strong plastic. You needed a knife to cut it to get it off. It weren't just a crappy old plastic bag. It was like, you know, a proper tough plastic. You got that off it, and then right, what now? Oh, and then you got more brown paper. And I undid this brown paper. It must have been wrapped about 20 times in paper, this thing, and it was really tightly wrapped. And eventually I got down to what is one of these connectors after all that. And if you'd have seen the amount of packaging, the package itself was like that big, and the connector inside was just that big. And they were brand new from Radial connectors, but they had a gold body on the back, very similar to this one, but the whole of the back was gold. And anyway, they're about £100 each or something, these connectors, you know. But I was going to throw them out, this bag. I had a bag full of them, like must have been about 150 of them in like a big sort of carrier bag, and I was going to bin them because I had that much military components, like capacitors like this, these capacitors, and they'd be the same. They'd be wrapped in they start off in a packet. We had wax paper inside with the NATO part number on, and then he undid that, and there was another packet, and then he undid that. There's another packet in a bag wrapped in like brown paper again with tissue paper in the middle, and then you get the capacitor, and it would just be one capacitor on its own. And obviously it'd have all the part numbers and cross-referencing, so the inventory, if you like, the military inventory, must have been enormous just for one radio. Obviously when that radio gets scrapped and taken out of service, all the spares end up going to auction, and that gives people like myself opportunity to buy things. But again, you know, just unbelievable the amount of work that's gone into packaging some of these components. But yeah, it's always amazing when you get a connector like that in a packet, and then there's this little label and it says peel back to reveal price, supplier's price. And then you get a right surprise when you pull the label back and you see just how much the Ministry of Defence have paid for that part from a supplier. But they're all really good connectors that come out of the MOD. They're all like Shunner, Radial, Andrew, you know, obviously Uber Shunner, we've mentioned that, but Amphenol, you know, none of this Chinese rubbish, you know, it's all real top quality, and often the gold plated with, like, you know, 18 karat gold and solid gold pins and things like that, you know, none of this rubbish that you get today. But that's why I always unwrap everything, you see, and it's amazing what you can find when you spend time unwrapping some of this stuff. But it just takes about, you know, all day just to unwrap a bag full of them. So yeah, this board I would have thought would have been replaced in its entirety, because it's potted and it's encapsulated in a lacquer or a resin. Then that would not be serviceable to component level, I would have thought. So they've probably stocked that board in a store somewhere, probably this entire module actually. It's probably field replaceable, and you know, it's just, again, they've got the part number there, information, and that's it, you know. Again, I'm not sure what they are. There's some kind of like a weird like RF shielding spongy stuff behind there. So there's obviously, I think they're the coaxial cables on the underside of that amplifier board here, which go off into this filter assembly on the end there, where that type N connector is. So yeah, that's quite interesting, is that. But if I just put that to one side a second, and then here we've obviously got the legend for what the connectors do. This is the filter assembly for the receiver, because obviously this side is the receiver on the other side, whereas what we just removed there is obviously the transmit PA brick. This looks like it's the interface for the connector on the front. Those connectors, they're all part of that. So the receiver will be interesting to look at. I'd like to look inside here in the in these filters to see what's what. I was hoping there'd be some RF relays in it, some teledyne relays, you know, or radial antenna changeover relays, but because it's got two RF sockets, you know, one for transmit and one for receive, there isn't a changeover relay. That's probably in another module that follows after this. But yeah, there's quite a bit there. I dare say we could probably power this board, put some DC on it, and drive it with a few hundred milliwatts from the SIGGEN, and then put a bird through line power meter on the output into a 150 watt load or something, and see whether we can actually get this thing to produce some RF power, see what sort of power we can get out of it. That might be something that we could do. People put comments in the bottom of the video and see if I want to see that. And yeah, it's a big heavy module. That must be a good 10 kilograms at least in weight in itself. Really over engineered, you know. But again, it looks like we've got these power transistors there that obviously modulate the supply rail, probably to a couple of these transistors, or maybe even all three, before obviously the RF output's then fed off into the power amplifier stage. So yeah, quite interesting. But I'd like to get into this antenna filter thing, but I don't know how you can get into that. Don't seem to be any screws from this side, and I don't know, unless it's bolted through on the side of this module that way underneath, but I can't see any way of being able to get that off. There's no screws or anything there. Technically there's some screws there. There's a screw there and one there, and these that hold the antenna socket on, but it's not got any screws on the top there apart from where the aerial sockets are. So I can't see just those two screws alone, that one and that one, just being able to get the whole thing off. I think there must be more to it than that. And that's the thing with these things, you've got to strip all sorts of other things down to gain access, you know, to vital parts of it. Right, we'll have a look at the other side, see if we can get into that. Okay, well, after a lot of faffing about, I managed to get this synthesizer unit out, which is what it is, a synthesizer. In the end there, it was very difficult because you undo two screws there and then turn this screw at the bottom that pushes it out, but it didn't want to come out. It took some levering with some flat bladed screwdrivers, again very heavy, it must be about 6 kilos there. So that's the synthesizer, and then earlier on in the video we removed the receiver, which is this unit. Just double check, yeah, that's the receiver. So we'll strip these down in a minute and see what's inside them. I noticed as well, I can't remember where it was now, I think it was on the synthesizer module, it says FM mod. There, look. So is it the case that this radio is an FM and AM transceiver dual mode, maybe? I mean, that's definitely AM is the transmitter, because we've got obviously a modulator as we saw, and we saw AM references on that, but that says FM. So is it an FM AM dual mode transceiver? Maybe it does both, you know, it's not uncommon. But yeah, I think we'll strip these down now and see what's in them. Right, so we've got the receiver unit. I've undone the screws now for this cover, so remove that. Again, more metal work, and now we've got these little modules that are plugged in, and they look like they're held in with these screws, obviously, in order to get at them and get them out. But there's all these little tiny modules on this side, and then I think there's another layer in the back, because there's something to there, and there's another layer in there, I think, of something. Yeah, we'll just remove these screening cans and so we can have a look inside. More screws. Okay, the moment of truth has arrived. Drum roll please. So after undoing all the screws, 1,000 years later, we've managed to get into it. There's another, there's so thick metal this, it's not thin crap. And there we are. Look at that. Wow. Some money's worth in there. So again, things like some of these transistors and things that are down here, these gold transistors, these GasFET, they're probably GasFET amplifiers. They're very expensive, they are to buy, and looks like there's a bit of, not sure if the modules actually come out, they do. To reveal something underneath maybe. There's definitely another module or another layer of something under there. But yeah, so if we have a look at the architecture as well, and in here we've got some crystal filters there, or a crystal, and Looks like some kind of bandpass filter. Potentially 3 coaxial cable soldered into there with a common output. Looks like some kind of a balun here. Transformer, RF transformer. This looks like some kind of a crystal filter or something, not 100% certain. Got a coaxial cable there, or wire going to there. I don't know what that is. It's something on the other side that comes through. It must be, because there's no sign of any connection to it. This looks like it's probably a local oscillator board, that potentially. That could be local on the multiplier stage, potentially. There's a wire there, which is, I think that's a micro coaxial cable, is that goes off probably to the mixer stage. So it could be, looking at this looks like the receiver signal coming in, and it splits to 3 different modules. Now these modules are the same architecture, so it could be that it's potentially, I'm only saying this off the cuff at the moment, but it's obviously got 3 front ends on it, because we've got the RF signal coming in going to 3 separate front ends, and that were labelled blue, yellow and green. So we've got blue, yellow and green, and then we've got an RF output obviously on the bottom here potentially. Oh, it comes in, sorry, on the bottom. So it comes in on the bottom from here into there, and then the output is on the top, which then goes to this. So in essence, I think it's a very similar setup where we've got the RF signal coming in potentially either from the bottom or the top, combined somehow together on there. Some kind of an input combiner, amplifier section, low noise amplifier probably, then to these 3 modules, and then probably an output on the top, or the other way around. This could be a wideband amplifier, RF amplifier IC. I've seen some of these before. Teledyne made something like this as well, which is a larger thing I've seen, where it's like a wideband RF amp with about 20 dB gain on it, and then it goes through like a mimic monolithic microwave integrated circuit. This might be the early version of it. This looks like a local oscillator board to me, because you've got a crystal here. You've got frequency adjust for it. I think this will be a multiplier stage, or at least just an oscillator, and I think the signal's coupled out into there, so there could be a mixer. This potentially could be the mixer. Potentially. That could be the mixer. But this is sort of basic as that. Looks like we've got RF in out sort of thing, and then we've got a ground connection there, and looks like 2 supplies. So these could be RF amp filter stages. They certainly look like some kind of a filter. We've got a gas FET amplifier down there. Now it is different. Or is it? No, they're the same. So it looks to me like as if this is a gas FET amp there. We've got input and output filtering, harmonic filtering, etc. We've got capacitive feed throughs. We've got, these look like varactor diodes at the bottom here, these 4, potentially varactor tuning for a bandpass stop, band stop and bandpass filtering here, these 2, and those again. We've got more varactors there and then there. So I think these have got front end varactor tuning, so that's probably what these lines are here. These will be these wires will be supplying voltages to the varactor diodes in order to tune the front end. Then with an amplifier, and that's the same on all 3 of them before it then goes back to here, and then ultimately then goes on to the other side, which is sandwiched. So I'm going to have to work out how to strip that down now in order to get this can off, but there's definitely another another layer there under here. Interesting. See what we can get to. So I managed to get that module out now, the one that was in like that, because I just wanted to see what this was. But I had to cut a few wires just here to get that apart, but so we can see. But there's definitely a filter there. It's a 40 meg filter or something that's there, and it's looks like it's soldered to the board just there, and then also just there. So this is probably the IF, or one of these is a mixer, and on the board as well. It looks like as if we've got like a potentially a local oscillator on this board, and a mixer somewhere, and then we've got then a filter here. So interesting. Potentially, I'm wondering if it could be a mixer as well as a filter, but I don't think so. It's possible though. When you look down there is a connection I can see just down there, I think, which goes through possibly. I'll have to have a look under my magnifying glass. What does it though? I'll just have a look. Yeah, there's a couple of connections I can just see in the edge of down there. There's a pin there, there's a pin there, and another pin just there. There's two pins down there, one of which I think goes into here, so it could be an integral mixer in there as well as a filter. But if I open it up like a book, have a look there. They're obviously the two pins, aren't they? There. So it could be the local oscillator. It could potentially be a mixer here as well. So the local oscillator and the mixers all on the same board. But we've definitely got three legs on there. We've got one on there and two there. So yeah, it says here filter, quartz filter, 40 megahertz. So that might be the first IF potentially. So that's interesting. That's a 39 megahertz crystal, I think. I think that's what it says on it. 39 point something megahertz crystal. So yeah, it's very strange, very strange. Right, I'm just going to see if I can get the other bit out now and see what lays under there. But now that I've got into it a bit more, I can see down there all we're going to get to is these PCBs, and I don't know what the value is of getting to those, but we can see what we can do. I can just see there's discrete components. There's nothing sort of RF sort of that stands out there, so that might be to do with the audio demod and processing underneath there. And this is the RF side, obviously, for the filtering. But it could be a spread spectrum radio. It could be something like that. For it to have three front ends on it, which then combine into there, potentially it could be like a frequency agile radio, where essentially it's got three front end receivers and it's frequency hopping and strobing around the band, and that's why it needs three separate sort of selective filters to prevent electronic warfare interference, EW, or electronic countermeasures. So it could be, you know, that's why they've designed it that way. But yeah, so we'll have a look at the synthesizer module next and see what's inside that. Okay, so this is the synthesizer module, and just got the lid off. There's a lot of shielding there and grounding for these little fingers that look like they come down near the ICs in that area. And then we've got this module there. So it looks like we've got a LM series voltage regulator, and then looks like this to me is a voltage controlled oscillator assembly, a VCO, and we've got an RF couple there. And these looks like down there are several boards all laid up, so it's obviously 1, 2, 3, 4, 5, 6, 7 boards, whatever, under there, all plugged in. So it looks like the top of this comes off and then it exposes all the boards. So that's an interesting little module. We've got the coaxial cable coming out there, going to here, voltage regulator obviously, and these ICs here. You used to see a lot of the time Plessey. They were very good manufacturers of, or predominantly, pre-scalers, programmable dividers, loop filter assemblies for VCO and synthesizer circuitry, and programmable logic arrays for synthesizers. Obviously, so you know, you used to see them, but we might see some Plessey ICs in here. I've got a Plessey designer's book, and it gives you all the IC data and everything for the Plessey chips that were for the RF side of things. Sort of, it's like an RF designer's book for military type design, which was written in 1984, I think it was. So there's a lot of vintage things. But yeah, we'll see if we can get into it. Again, it's potted again, lacquered. No way you can get these ICs off, but at least I've left the part numbers on the ICs, so you can see those as well. And a lot of MC logic there, MC chips, quite a bit of things. So we'll have a look deeper and see what we can see. Okay, we've got the synthesizer module apart now, and found some interesting bits in this which we'll just review. First of all these cards were all plugged in. Took a lot of screws to get these out and this thing apart, but anyway, we did it. As we can see there's a lot of logic ICs and various things that form the synthesizer, no doubt programmable dividers, pre-scalers and synthesizer ICs. Whereas most modern day electronics, obviously all that can be contained in one chip, but back in this era these cards make up the synthesizer as a whole. And we've got some interesting components on here as well, because we have some wideband amplifier devices as well. And I think in this section here, this was a screening cam that I had to remove off this bit. So this is sort of the RF side of things. But again, we've got these rather expensive GASFET devices, or they're either that or mimics, monolithic microwave integrated circuits. And again, these sort of in the RF path there, these are sort of wideband devices as well, amplifiers. I've had some similar devices to this, a little larger, that look sort of like Alka-Seltzers with 4 legs on them, and they're sort of like RF in, RF out, DC volts, I think it's 5 volts or 12 volts or something of ground, so it's 4 legs, a bit bigger than these, and made by Teledyne, and they were sort of really wide banded RF amplifiers with about 20 dB gain, only a couple of dBs noise. So really sort of advanced spec mimics from Teledyne that I've had. But again, some of these ICs are in the RF section, so that these potentially could be wideband RF amplifiers. And indeed these ICs are very sought after components, very expensive to purchase, so I'll probably be salvaging these at some point and keeping those back in my parts drawer. But other than that, not much else really on there in this part of the circuit. Now if we have a look at the rear of this module, just remove these, there's obviously another PCB in there, sort of a low frequency side of things. Interesting, there's a row of transistors down here, so I'd be interested to see what function they have. But on the back here, I did find something that was quite interesting. We've got a VCO module, which is this, with obviously a RF connector on its output there. Looks like this coaxial cable goes in the side there, and we've got some feed through capacitors with various voltages we can apply, so it might be interesting to salvage that and play around with it. We've got a couple of voltage regulators, LM series voltage regulators. Again, they're quite expensive to purchase and they look in good condition, so I'll probably remove those as well. And we've got a Marconi, which I found sort of tucked. It was sandwiched down here, bolted down, and then we've got this Marconi crystal oscillator, I think it is. Let's just zoom in and see if we can get some more detail on it. So if I read that correctly, it's 3.2 megahertz, and that's a crystal oscillator. It looks fairly simple to reverse engineer and run. It's only got about 3 or 4 pins on it, so it's not rocket science to get that working. Again, something else that we can salvage, and it just shows you the sort of quality control that goes on with these components, because this has got its own individual serial number. So there's an audit trail, a trace back to not just the manufacturer but the production line, the person who maybe assembled it, and the tooling. So if there's any problems with this component, there's traceability all the way back. And of course, your military radio equipment like these LM series voltage regulators, they'll be the highest standard, highest spec components that the manufacturer can produce. So, you know, all really good components really to get out of that module. The rest of it's just all metal can, and there's not much else really salvageable in there, to be honest. Again, plenty of gold pins, gold plated pins in the days when they did actually properly gold plate things with quite thick coating of gold. So yeah, onwards and upwards. Right, this is the inverter unit, which we finally got out of this enclosure here, which was quite tiresome trying to get that out. Lots and lots of screws and bolts to undo to get this out, and I've undone this heatsink at the side there that was held in with 2 screws, so we can have a look at these transistors. But it's quite interesting really, because on quite a lot of military radios, nearly all of them that I get here, they've always got inverters in them for some reason. And I think one of the reasons why they employ inverters is so that the supply rail that the radio equipment is provided with can vary in voltage quite a lot. And I think also it stops transient spikes and various other problems that might be encountered with unregulated supplies that are providing powerful radios. But one of the interesting things is it's obviously got 3 coils, big coils on this. It's quite a heavy item. I mean, there's a good kilo there in weight. A real big thick heatsink plate on the bottom there as well. So there's a lot of engineering gone into this in order to make sure that it keeps cool, and plus this is bolted then to the chassis of the radio. So we've got 3 coils here, and it looks like as if each coil's got multiple taps on it as well for different voltages. So this thing could produce a whole manner of different supply rails, and it looks like that's evident there because we've got a cluster of orange wires, purple wires. So it could be that, for example, orange carries say plus 12 volts, purple might carry plus 5, or the orange might carry the lighter oranges, and reds can carry different voltages as well as the yellow. So it may well be that there's different supply rails coming off here provided by the taps on these coils, but what voltages they are I don't know without the service manual. But it looks like as if this is a switcher driver. It looks like these are the switching transistors here, and then we've got a load of diodes here, big power diodes. These are not your little flimsy silicon diodes that you normally get, like your 1N41, 4001s, etc. These are, you know, the full Monty, big boy stroke power diodes. This is the driver board obviously for these transistors. We've got the these top-up transistors mounted with heat sinks on them, and a few capacitors there. But one thing I do notice about this really, although it's a big inverter, There seems to be an absence of smoothing capacitors. You know, there's no sort of reservoir capacitors in here that I can see anywhere. It's absent. So it's probably the cumulative effect of all the capacitors that are on the boards that are actually employed in the system as a whole add up as one larger capacitance, and thus then obviously it can potentially smooth the output of this, because otherwise the output without capacitance will be quite choppy and sort of unstable. So, you know, obviously the rest of the modules that we've taken out have all got capacitors on them, you know, and like these littered all over the board. So these are probably what smooth out the output of this. When you add all the different capacitors up that are on all the boards across the supply rails, it probably then acts as a smoothing agent. So again, different concept in design. No big fat electrolytic reservoir capacitors, anything like that in this product at all. I can't see any other items mounted under this transformer. These transformers have got some pretty thick windings. I mean, when you look at the diameter of a wire on these transformers, I mean, this is sort of getting on for big boy stuff. This is not the thin wire that you normally see on a lot of transformers in audio visual equipment or other electronic equipment that's sort of this voltage class. So this is designed to output significant current, and naturally if it's providing enough current to you know, make this amplifier, which I surmise, and we'll have to test it, I think this will do about 100 watts. I mean, these transistors alone can probably do 30-40 watts a piece. When you add them all up cumulatively, I reckon this is well over 100 watts output possibly, particularly on SSB mode or AM, or whatever mode of transmission it uses, perhaps even FM, but CW. But again, you know, this has got to produce the current required for that. So obviously there's quite a lot of emphasis going on here with the diodes that are employed on this heatsink in order to rectify that inverter's output. So again, yeah, quite interesting. Little PCB board there, just plugs in, you know, and then we get our little driver board rather, just connects in and Bob's your uncle, you know. So yeah, nice little unit. But these transistors here, I'm not sure what they are. So let's just zoom in and have a look at these. So these are 2N3772s with the look of it. I think they might be related to the 2N3771s, quite common series pass voltage regulators that are used on power supplies. Typically supplies under 20 amps tend to have a 2N3055s because they're rated at 15 amps collector emitter current, whereas the 2N3771s are 30 amps. But it'd be interesting to see what the 2N3772s are. I'm not sure if they're NPN or PNP. Maybe the 771's NPN and the 772's PNP maybe. I think I've got some data books here actually. So let me just have a look to see if I can find the data book. Okay, so I found my data books. I don't think it'll be in that book, Power MOSFET. Won't be in that one. Probably in this one. So let's have a look here. 2N3772s. No, we're not far off. 2N3. 3055s. 2N3 7719s. I skipped a page here. Let's have a look. No, 7.4s. 7.7s will be up here somewhere then. 2N3. Oh, here we are, look. Here we go, look. Right. So. Oh, it's NPN. 2N3771, 2N3772. So, let me just have a look and see what it says then about them. And hopefully. Oh, I see, right, so a 2N3771 is a 40 volt transistor, and a 2N3772 is a 60 volt transistor. I'm just looking at the current here. So a 2N3771 has got a continuous and a peak rating of 30 amps, whereas a 2N3772 has got a continuous rating of 20 amps and a peak rating of 30. So that's interesting. But yes, NPN, 150 watt or thereabouts dissipation. So it looks like it's very similar to the 2N3771, which is also a transistor that we use in lots of power supplies, etc. So that's the specification there, and you can see that there, the 2N3771s and 2s, the differences between them. So again, very useful transistors, very expensive as well, even in today's price regime. If you're getting decent quality transistors from renowned suppliers, not the usual rubbish that you get from some other places, but these transistors will probably have, you know, not just made in particular for the military sort of market, but will have decent quality construction and better production standards. And obviously these transistors, being manufactured back in the good old days, will have got substantially sized dies in them, and so on the substrate, so less prone to failure than perhaps some of the more modern transistors. I've seen some of the 2N3771s and 3055s of the modern versions of them, if you like, have got substantially smaller wafers in them, and the bond wires tend to fail, and they go weird short circuit problems and cause blow-ups. So, you know, these are very expensive transistors to purchase, so obviously we'll be harvesting those, definitely, these transistors. Not too bothered about this little one here. I've got plenty of these sort of style transistors, a lot of RCA ones that I've got. I'll not be salvaging those. I don't think I'll bother with the diodes. I've millions of those in boxes, these old-fashioned diodes. It was quite commonplace in the 1970s, 80s, and indeed right up to the late 80s that you got bridge rectifiers formed by these sort of diode assemblies rather than the single square package. But again, some people might find these salvageable and obviously interesting for them. But for me, not too bothered, to be honest with you. I'll just salvage the 2N3772s because these can be reused again in power supply repairs and things like that. So that's the inverter. Quite an interesting little module. I mean, to be honest, there's lots more other parts obviously we can salvage out of this. If you're really, you know, desperate for sort of spare parts, you can get quite a lot of really good things off this, you know. So yeah, it all depends what you want from it, really. Right, we'll have a look at the whole thing together now. Well, I just wanted to look back at the RF amplifier section a second, because I noticed something that I didn't talk about earlier, which is this device up here. And that thing looks like to me either it's an RF relay for switching the RF path, because we can clearly see on the left here we've got some kind of an RF signal coming in. These look like supply lines in the middle, and then the output there goes via that capacitor down, obviously, to drive this transistor. So this is either an RF relay or it's an amplifier module that may be bolted down to the chassis, but I can't quite see fully at this stage. There are two transistors as well that are mounted under these legs there. Look like TO3, similar to the 2N3772s that are bolted there, but I can't get into it. Looks like as if this thing sort of comes apart, this back bit off of this bit, in order to get to them, because they'll be just under there, you know. but I can't figure out how this comes away. I've taken all the screws out of the top here all the way along these screws, and there's none of those left in, but I can't, no matter if I pry it or whatever, it just does not want to shift unless it, oh hang on, there we are, look, I've been trying for ages. Ah, right, so we've got a few transistors there then, another big piece of metal. Right, so looks like as if I just need a rag, I think, if I can get a little rag and a bit of foam cleaner, might be able to see what these transistors are then. Let's have a look here. These are RCA, are they? And let's just see what these are then. They're certainly filthy, say that. So these are 2N6258s with the look of it. Looks like I need a good polish up. Certainly tarnished and stained are those, so yeah. Looks like as if for a unit that's sealed up with no air ventilation, it's certainly filthy, I'll say that, when you look at the bottom of that. So that's it there, and of course we've got the studs of the power transistors on this board, RF power transistors bolted there, and it looks like as if these screws here may allow the modules above to be removed and and come off. Looks like we've got the antenna filter assembly here, which I might be able to unbolt now and get to that. So that's something else that we can perhaps have a look at. So it looks like the modulator transistors, if it is AM, then this particular thing, it's labelled up here PFM mod. So it might be some kind of digital modulation, maybe, something like that. I mean, obviously we looked at the receiver and it seemed to have 3 segregated front ends with individual electronically controlled filtering using varactor diodes and pin diode switching, so it could be some kind of a sort of spread spectrum type radio. But what we'll do, we'll see if we can strip this unit down a bit more now to reveal more detail about the antenna filter and the RF power amplifier module. Okay, so we've got the screws out now for the antenna filter, so we can remove this module and have a look inside. So this is it. So we've obviously got the RF in, leaving the high powered RF amplifier coming in here, and then this looks like a harmonic filter, because we've got both, well, series inductors, we've got capacitance in there into different chambers obviously. So this is some kind of harmonic filtering, and then it passes through, as you can see there. And that, to me, I'm just looking at this component down there. Yeah, this looks like an inductor, but that comes in there, and then we've got this strip line, this transmission line, then up to the top section, and this forms a directional coupler for both forward and reflected power, because we've got a track there and a track there. Obviously incident power going this way from left to right, if you like, or from bottom of the picture to the top, that'll be sniffed by this transmission line here. And it depends what direction the diode is as well, because you can have it so that this can be unidirectional in essence, depending which way you put the diode. But basically power going this way will be coupled mostly onto this, and then likewise power coming back this way from the antenna. If there's a mismatch, RF travelling back the way will be coupled onto this most than this one, so therefore this will be for the reflected power, and this will be for forward power RF reading, so it can know the VSWR, whether it's running into an open circuit or a mismatch, that kind of thing, and thus control it. Looks like we've got an IC here that's soldered on the board there in order to probably a logarithmic amplifier for these directional coupler sensors. There'll be Schottky diodes on these as well, and some capacitance, and then radio frequency choke, so you get a DC level coming off which is proportionate to what the RF signal is that's been coupled onto them. And then likewise here we've got the final antenna matching and filtering network here, which then goes off to the N-type type N socket. So there's not much really to look at there, but it's just general sort of antenna filter for harmonic filtering and matching, that kind of thing, and a directional coupler, all part of one thing. So yeah, be interesting to disconnect this, and then we could essentially then connect this into an RF adapter to one of our RF power meter, or this socket here, and then we could then provide the amplifier with a drive signal, figure out its power, which would be quite easy to do, and then give it a drive, and let's see how much juice we can get out of it, see whether this amplifier works and what sort of frequency range in UHF that it's designed to work at. I would say, judging by the length of these transformers, it could be around about the 420 megahertz frequency range to 430 megahertz possibly. So be interesting to have a look at that and see what more we can do. I mean, it might be possible, depending if there's any complicacies around this device here, to be able to drive this amp first with a low level RF signal, so that it obviously gives a significant drive output to this then. Otherwise we'd have to use a separate amplifier and then connecting the drive source into there, which I've got some Calmus amplifiers, wideband RF power amplifiers we can use for that. So we can have a tinker with that and see what we can get out of it, but be interesting to see if the amplifier works. So this is a close-up of the antenna filter. As you can see, all the intricacies inside. And then the final output there. Before it goes off, it looks like a lot of these capacitors are select on test. Obviously, you know, put them on as part of the alignments on the filter, so they can tune it and spread the coils as well, like this coil here. They can spread the coil and put the capacitor in to get the best results that's required, and then off it goes then to the type N socket. So this is a close-up of the RF power amplifier, and there we can see the driver stage. And all those tracers, inductors, surface inductors and capacitors. And then we've got obviously the biasing arrangement, obviously the transformers, and you can see their general construction. Again, very expensive, this tubular transformer, and you can get them with dual conductors inside. I've got some microwave amplifiers here that have got the two conductors inside. Some are singular conductors, use rigid coaxial cable. Others are proper RF transform where there's two internal conductors, and we've seen that on my channel with the Marconi RF amplifier that was filmed a while ago. If you look at that, you'll see some of the things there. Again, these are SMC connectors there for the RF signals, SMC connectors. So again, I've got some adapters here that will allow us to connect. The difference between an SMC and an SMB is, of course, an SMB just pushes on, and an SMC pushes on but also has a screw thread in it. So it's similar to an SMA but smaller in many ways, and it's similar to an SMB in the fact that it pushes on, but it then screws. There's a screw thread, so then obviously it can tighten down. So that's how that works. Okay, so after a lot of messing about, managed to get this RF amplifier board out the case, so we can have a look at it in detail. Now it looks like it's very high powered, is this amplifier, maybe somewhere around about 100 watts thereabouts, based on these transistors. The probable rating of these transistors might be about 40 watts each. So you know, you're looking at least 100 watts, I would have thought, output power at UHF. Now, just looking underneath here, we've got lots going off underneath, a lot more going off underneath than there is on the top actually. But we've got 4 potential divider networks there, which appear to provide biasing, when we look over very carefully, to the big PA transistors, because we've got a potential divider there. One device appears to connect to ground on one side, so if we zoom in we'll be able to see that better. But possibly one's an inductor actually, it may well be, but so we've got this device here that literally solders, when we turn it over, between this pad here, which goes to the base of this transistor and connects to there, and then the other resistor, which is on the other, to the right of it, or inductor or whatever, it solders down to ground here. So I think this is either a potential divider for the biasing. Likewise, we've got the same there. So on that side as well, we've got another leg from the device solders from there to there, and then the other device, which you can see the leg here, is that other resistor to the left of it there, which goes straight down to the ground chassis. So this looks like as if it's some kind of potential divider that does 2 things, and it's supplying voltage then onto this track obviously, which is then going through this radio frequency choke, and then ultimately arrives at the base of this transistor on this pad here. So that's how that's derived. We've got the RF transformer as well, so looks like as if when we look back over here, we've got the coaxial cable with the RF input here. The RF signal comes in and connects, and it looks like this green wire here put some biasing on potentially to switch this path. I'm not sure if there definitely looks to be, that looks like a pin diode, that potentially. I'm not sure if I can get some more detail. This looks like some kind of a diode. These are probably inductors perhaps, or resistors rather, that connect down to ground. That looks like a pin diode to me, does that, definitely. And then we've got another resistor there. So is this just sensing? I'm not sure. Might be a sensor of some description there. So, but we've got looks like 4 ports on this splitter. So you know, we've obviously got 1, 2, 3, 4. So we've got 1 port there which connects the RF signaling onto port 4, and then we've got what appears to be a transmission line. This looks like under this yellow wire here, the other side, which is port 1 of this splitter, goes via this solid coax then up here to what looks like a terminating resistor, substrate resistor. This will be 50 ohms terminating resistor. This again's beryllium oxide substrate resistor, which is then bolted or bonded down to the heatsink, and the other side then is connected to ground. So they can dissipate quite a bit of heat, they can, and RF power into 50 ohms. So this is a 50 ohm load in essence, and that looks like as if it's yeah, there's two screws that bolt that down to the heat sink. So that's the termination, if you like, for the input combiner, and then the output then pins 2 and 3 then solder onto the other side, which then go directly then to this leg of a transformer, and likewise this leg of a transformer. So if we analyse this, RF signal comes down here, goes on the inner of the coaxial cable, which is down here. Now you can get these, and I do have some here that have got 2 inners inside them, as well as an outer solid outer tube like this, but this is a singular one. So RF comes in on the outside, and the inside rather comes up the inside of here, and it starts to transform onto this outer jacket, and or can do, and then arrives there, comes out and shorts effectively to the outer of this one. So then obviously we get RF transforming from outer to inner, inner to outer, etc. So this is a proper RF transformer. Ultimately then, after amplification in this, it gets passed across to this. Now what normally happens is, on this kind of RF transformer, is, depending on how they've designed it, you can get it where the collector for the transistor is connected to the outer at one end of this transformer. So the outer jacket connects then one end to the supply, the other end to the collector of a transistor, and as a transistor starts to switch, amplifies, then in essence the RF power that is derived on the outside of the tube is transformed onto the inner, and then the inner then couples the output out, and again you'd have that sort of, if it's like in a double-sided transformer like this is, you'd have one side connected to a 50 ohm load for any return power coming back would be dumped, or to balance the transformer, and then the it would be impedance matched to 50 ohms as well, and then the centre of the coax then would have the amplified signal on it. But this is actually appears to be on the input, to be honest, to that device. So it looks like it spreads it out on this. So I think it's like I'm probably on the, looks like it's on the RF in, connects to there, then on the out of that. So the out of that then jacket might connect there, because I think this is a multi-layered PCB as well. So we've got biasing onto the base of this transistor, and then we've also got the RF as well via this transformer coupling onto there. We've got a resistor here that connects the supply to the collector, and if we turn it over, we've got that resistor there, which is this 15 ohm resistor. So we've got the supply coming into this terminal, which feeds through to then this resistor, which then goes through the board there at that junction and solders directly, and that's a wire of the resistor to the collector. And that's the same on the other side there, no different, exactly the same again. So it's obviously getting its supply from the yellow wire, and then I think as well there's a two-part thing. I think it's going to the potential divider to derive bias for the power transistors, but it's also arranging bias then for this base of this transistor, the drivers as well. And then we've got the RF transformer as well, which I'm sure this RF transformer, I think one half of it would certainly be on the collector side perhaps, and the other side would be for the input. So yeah, we've got some very strange trickery going on here with the way the circuit board has been designed. Everything's crammed into a small space, but I think this is a multi-layer board. I don't think it's just 2 layers. I think there's another layer in the middle, so there'll be some other connections going off, because when we look at this, all we can see is a resistor connecting to the collector, and there's no other print there which goes off anywhere. So there's got to be a way for this collector then to be able to supply its RF to these two capacitors. So I think there's probably another trace in the board somewhere which connects off to this side somehow, and I also think that's where they've designed it, so that it's all crammed into that small space. Because as we can see on the output of these PAs here, we've got one PA connecting to one side of this transformer, and then the other PA again on its output connecting to this side of the transformer. Again, there's a 50 ohm resistor there as well on this side. So on one side of that transformer we've got a 50 ohm there dumping it before it actually gets, with the look of it, to this sort of oh no, that's the output, this combiner, that's the output combiner, and again port 3 goes to this resistor. Port 2 looks like as if it connects, if I can get this right, port 2 connects there, so that's port 2's connection. Again, there doesn't look to be anything on the top of the board which shows its connection anywhere, but I can assure you it will be going off probably somewhere. That's it, there's a coaxial cable. That's the RF output then. So port number 2 is yeah, that's port number 2. That's going off to the coaxial cable output. So that's there. So that's the output. That is going to the 50 ohm termination. Yeah, I believe so. Yeah, because that's that micro coax, so it's going there. And then this part here is doesn't show anything on that side, but the inner connects down to there, I believe. No, there's nothing there, I don't think. Yeah, that's right. So the inner must be transforming to this side, so we've got some RF going on that transforms that way. Yeah, and then we've also then got the RF again on this, which transforms from the outer then to the inner, and then comes out and connects to that port there. This port here is obviously connecting to port number 4 on the combiner, and port number 1 then connects off to what is the top amplifier here, the same again. So we've got an RF transformer. There are some connections though which we can't see in the middle of the board, which then arrange this transformer in such a way that the RF can couple from one side to the other, but that's hidden under this because it's actually partly stitched together underneath as well. So, but it is a biased amplifier then, so it is like a class A, B, whatever amplifier, because we've got biasing to these transistors as well as these two as well. So it's quite a realistic design. So yeah, we've got a mixture then of underneath. We've got the input and output combiner. We've obviously got 2 driver transistors with biasing networks that also provide bias to these 4 power transistors. We've got a terminating resistor, 50 ohm terminating resistor to balance the input transformer, as well as on the output there. Anything coming back will be dumped into this terminating resistor as well, if a VSWR is high or whatever. So these obviously get quite hot, hence the reason why they're bolted down to the heatsink. So yeah, quite interesting little design. So all salvageable components. These are salvageable because they can come in useful as 50 ohm terminating resistors that can be saved and used later. These little combiner things are also useful, and then of course the RF power transistors themselves, all perfectly salvageable, all good little parts that, you know, we can keep. I don't think there's anything else on there that I'd be interested in keeping. These look like temperature sensors. No, I don't think these are going to be temperature sensors. I think these are probably going to be RF pickups, because they're not lent over the tops of the transistors with silicon heatsink compound on them. So yeah, that looks like as if there's some kind of RF pickup things. It did look to me though like there's a little pin diode switch down there somewhere, but I don't know. It does seem a bit strange where that green wire solders there. That looks like a pin diode in the middle. So there's some shenanigans going on down there as well. But who knows? Who knows? We've got some other components here. To me, I'm not sure what they are. I'll have to look under my spyglass. They do look to me like capacitors myself, which they may well be, but sometimes you get weird diodes and things in packages like that as well, which I've seen, special diodes, but I don't think that's the case with these. I was going to have a look with my little spyglass that I've got here, so we could have a butcher's together and see what that is. So let's just have a look, see whether we can get in with further detail. So yeah, what are those then? What are they? They look like as if potentially, I don't know, the solder, yeah, the capacitors, I think. That's what they look like. Definitely look like capacitors. Yeah. That's that terminal with that 15 ohm resistor in it. Yeah, I think one of those is an inductor actually. I think one's a resistor and the other's an inductor. So I definitely think there's some other print in the middle of the board which we can't see. And yeah, I think there's definitely another layer in the middle of that board. And we can't see that. So yeah. Looks to me like as if there's some definitely something going on down there. That is definitely a pin diode, I think, that there. Either that or it's a Schottky diode for rectifying, or something in the middle of that little cluster there. There's some weird thing. It could potentially be connected, that resistor there. It could be that this output port on this combiner there solders to this resistor, as at the same time as soldering to the inner of this coax, which ultimately goes up then to this terminating resistor here, which we've got. And I think what happens is that when the VSWR is high and RF starts to be decoupled here for dumping into the 50 ohm load, a proportion of that will be going through this resistor, get rectified by this diode, and then that then ultimately there'll be a capacitor on the other side of the board that we can't see, but that'll then solder to this green wire, and that green wire then will take a DC signal off like a sample of the reflected power that's coming back. So, and I think that's how that works personally. I think that's some kind of a monitoring circuit via this, because any return power, IVSWR, whatever mismatch, will get reflected back out on this port. It'll get dumped on that port and then dumped into that resistor. So it'll need to know what's going off. So that's probably what that little circuit is down there. I don't think it's a pin diode as such now. I think that's like a Schottky rectifier diode for rectifying the UHF frequency into a DC level. So yeah, very interesting. No doubt we could probably connect this up if we really wanted to, depending on what voltages and things that it runs at, and get like, you know, a signal into it, and get like, you know, maybe 100 watts or something coming out. But I think these transformers would be fairly narrow band in frequency range. It'll probably just be for the UHF military allocation bandwidth, and getting it out of band onto other frequencies would probably be extremely difficult. But the transistors themselves are actually quite useful, so they're definitely something I'll be salvaging. And of course, if anybody wanted to experiment you know, in getting one of these amplifiers running. I dare say it wouldn't take much to get sort of one of these wired up and some RF power coming out. Definitely looks like on this board here we've got this RF power amplifier module bolted down, because there's two big screws holding it in from underneath, and again they'll be biasing on these as well, probably the very same fashion as these. So yeah, it does look like it is sort of like a class AB RF power amplifier. So yeah, very interesting. Okay, so after all that, this is what we're left with. This is the whole unit, all the parts. So we've got at the top here the receiver unit, which we took apart, all the boards, and the what looks to be three front end selective front end filters, which are switched. Looks like some kind of multiplexing goes on, or some kind of frequency selection between them. Seem to be Varactor tune front ends. Then we've got obviously the mixer IF stage at the back there, and some crystal filtering and selective switching with the 3 inputs and 3 outputs, which are then fed off. We've got the VCO assembly as well beneath it, and synthesizer with all the plug-in boards and cards etc. that were removed, that went in there, and some RF goodies with the sort of gas FET amplifiers on them, which we looked at earlier, which are rather expensive, or these mimics, these gold ICs there that are well worth saving. All sorts of interesting salvageable components on there, wideband amplifiers, you name it, probably pre-scalers and programmable dividers. And then we've got the VCO bit as well at the bottom there, worth playing around with, some voltage regulators etc. as well, and a Marconi crystal oscillator as well. And then we've got the RFPA and antenna filter assembly with the directional coupler reflectometer in it, harmonic filtering, and obviously the type N there, which is salvageable. We've got the RF power amplifier, very expensive transistors, very useful in future repairs. I'll salvage all these UHF power transistors as well, because these are very expensive to buy. And there was some nice 50 ohm terminating resistors underneath, and these frequency splitters, combiners, call them what you will, they're salvageable. The same there, and again this PA module at the top there, that power amplifier module, will salvage that and these transistors. We've got some RCA TO3 transistors on the back there, they're salvageable. Some more components on there potentially with the heat sinks, they're worth saving for these transistors. So yeah, that's that power amplifier section of Modulator. And then we have on this side here all the boards that came out, the Synthesizer, sort of these larger boards here. And then we've got the big power inverter, which if you remember had the 2N3 772 power transistors on the back there. They're definitely salvageable and worth having. The diodes as well, very high powered diodes, very useful for anybody who wants to make power supply projects. Plenty of copper on these for copper salvaging, or if somebody wants transformers that they can play around with and obviously manually switch themselves and experiment with. That's all there. And then of course, not forgetting, we have a great big aluminium case as well, which again for metal recycling etc, potential there to get a bit of money back, and getting rid of all the metal parts, aluminium screening cans. Soon adds up. I mean, the whole unit itself must weigh about 20 kilograms. There's plenty of aluminium in it, so plenty to salvage. So all in all, I think I've really enjoyed this. It's been very good. First time in a long time that I stripped a military radio down. You don't often get these on the channel where we do strip downs and tear downs. So if you'd like to see more of these, please leave comments in the description below, because obviously you know, it might be something that people want to see more of on the channel, so by all means please give me feedback. And yeah, so if you want one of these, I'll leave a link in the description as to where I got this from. I'm not sure how many more are left, because they did seem to be popular, but you can have a look, and if there's still some available, then by all means you might want to purchase them yourself, so you can strip them down and take all these interesting parts out of them. So with that, thank you for watching, and hope you're well, and catch you in the next one. Bye for now.